I made a video earlier, and it was basically me just like reading, trying to, so I gave myself a assignment today for, I'm getting ready to write the first part of the Axioms chapter 2 of my book. And so I was like, I'm still like trying to figure out like how to open it, how to open the chapter up, but I think I figured it out. So that's why I'm like posting this now. But I made a video earlier where I was like trying to look for the logical axioms in like Jech and Kunen, and anyway I ended up finding them in my old notebook from the class I took with Joel Hipkins in 2010 logic class. So these are basically the 3 books I'm going to be using for this axioms chapter. And I also want to talk about Jech and Kunen because like they're both so important. But I've recently had a greater appreciation for Kunen, which I already had. I mean, I like Kunen, but it's like I was like, oh Jech, that's why I was going to Jech. But in grad school, they'd say you got to read Kunen, you got to read Jech, it's Jech, and then go to Kunen for the details. So, but I would say, yeah, Kunen, it's really nice to read these introductions now. I mean, compared to like when I was first reading like the introduction sections when I was like in grad school and stuff, it makes so much more sense now that you like see the bigger picture, and it's like so helpful, and like it's just packed full of information. Okay, so I just wanted to like read a couple things from there that I really liked, and so I think I know what I'm doing for my next chapter. But I just want to I'm mention a couple things. I'm watching what's it called again? I just forgot. Problemista. Oh, it's so good. It's so good. Just watch it. If you like art and crazy things. Also, I was going to mention a story about my glasses because my glasses were broken in like some of the videos and stuff recently, and in real life too. And but I couldn't get them fixed, and like anyway, I was at the bus stop and I found these glasses, and I have a weird prescription where it's like I have to see far away and close, and like I have an astigmatism, and I was like they like work perfectly, so that was a miracle. And I thought maybe it's a placebo. That's like I've taught a class with like talking about placebos before and like how effective they are, and I thought maybe I like placeboed myself because like I was like they work perfectly, so that was cool. So yeah, I just wanted to just kind of just mention a couple things that are mentioned in here, and then I originally made this video of, well, I was like couldn't find what I was looking for, and then I eventually found it in here. But I originally made this video because like I was trying to make myself like I have to do all these little things that I don't want to get involved with before I'm like writing the chapter. It's like little things that I maybe don't quite like, you know, have everything worked out. It's like, or I don't want to like, it's a lot to explain or something. And so I have these little tasks that I give myself when I'm getting ready. And one of the tasks was like looking up logical axioms in these books, like to refer to stuff. But I have something, I'm going to do something a little different. Okay. Yeah, so I'm just doing the first part. The first part of chapter 2, I'm hoping to post like this weekend, like Sunday, but it might be like Monday or Tuesday or something. But it's going to be question mark for the intro. I'm getting that, but then it's gonna be like I'm giving it away but it's gonna be like this little, well, I'm not gonna say it because I want to make sure I can, it's not anything like crazy or anything. It's just a totally normal thing to include, but I just I gotta make sure. But then it's just the axioms. Well-ordered principle is equivalent to axiom of choice. And then I'm getting into stationary sets. I want to like mention stationary sets and talk about model cardinals because I'm trying to kind of keep diving into large cardinals and like yeah, so you'll see maybe how I get that involved in this first part, but then there's more parts to chapter 2, and the second part is Ramsey's theorem, so I'm going to try and connect that to the axioms, and it's definitely going to be visual. Yeah, I want to include that because I also want to include Ramsey cardinals, so a little bit of that, and then also Gödel's incompleteness theorem, which I really like Kunen for the way he talks about it, because it's like, I mean, you know, he keeps it like up here. Like there's so much to say about proof systems and logic, and so yeah, yeah. So I just really, but I hopefully I can include Gödel's incompleteness theorem, you know, in some amount, in some sense or something like that. That's my plan, and then the painting. Okay. So I'm just wanted to like appreciate Kunen and Jech in their intros here. So I just wanted to read the part that like I like the way he's like this book is, what is it called? An Introduction to Independence Proof. So in this book, we'll study techniques for showing that statement phi is consistent with ZFC. Phi will be shown to be independent if we can successfully apply these techniques to phi and to not phi. This will always involve two separate arguments. There are also many statements which have been shown to be consistent, but whose independence has remained unsettled. Okay, and he's talking about diamond and Suslin's hypothesis, Martin's axiom, and CH as other examples of like independent statements, which I might want to include diamond. Okay, and then because I think that might be visual. And okay, then this is a good. I'm gonna like kind of I'm gonna start including credits and stuff because a lot of it's just been Jech and like Joel Hampkins. So I'm gonna like include like make sure I include credits like specifically. But I like the way he's like, why are we doing this? It's just like okay. However, in this book, we're concerned with establishing results like CH is neither provable nor refutable from ordinary set theoretic principles. In order to make the statement precise, we must say exactly what these principles are in this book. So I like that the way of getting into it. It's like we want to head towards independence, so we have to say independent of what, and so of these principles. Okay, we have defined them to be the axioms of ZFC listed in the introduction. The assertion CH is neither provable nor refutable from ZFC is now a well-defined statement in which we shall establish in chapters 6 and 7. Okay, so I like that, and I'm going to kind of like come at it from that perspective. Like we want to prove independent statements. So what are the things you're independent from? Okay. And I'm gonna think of like the axioms are like the colors in art, or yeah, something like that. Okay, okay. All this stuff, I think that like in writing, like getting like all the outline is like that's the hard part. Because otherwise, then if you can break it down into little pieces, then it's. I'm hoping so. I think I'm feeling pretty good about this, so that's why I'm maybe posting this. But yeah, it's always a challenge. But I did feel like a little bit better today after like just not knowing what to start with. But okay, I mean like Russell's paragraphs. I mean, I just don't want to. That's a great place to start though. So I'm just reading from Jech, and he's talking about Russell's paradox and how we have to. The safe way to eliminate paradoxes of this type is to abandon the schema of separation and keep its weak version the schema of comprehension and keep its weak version the schema of separation. If P is a property, then for any x there exists a set Y which equals the set of all x in x such that P of x. Okay. Kunen has some very nice things to say about like what's a property and how we have to put the property in this formal language. And we build this formal language and then do all of our principles can be said in that formal language. Okay. Once we give up the full comprehension schema, Russell's paradox is no longer a threat. Moreover, it provides this useful. Wait, let me go a little bit later. Okay, this part actually I didn't quite understand. So replacing full comprehension by separation presents us with a new problem. He says the separation axioms are too weak to develop set theory with its usual operations and constructions. Notably, these axioms are not sufficient to prove that the union of two sets exists or to define the notion of a real number. Thus, we have to add further construction principles that postulate the existence of sets obtained from other sets by means of certain operations. Okay, there's my question. I might ask this like on like Math Stack Exchange or something. Is he saying he says that the separation axioms are too weak to prove like the union of two sets exists? Is he saying that if you had comprehension, if you had this, I think of like comprehension, like full comprehension, like this like magic wand, it's like whatever property I can name and all the sets, all the things with that property are a set or something. It's like this magic wand. Is he saying that if you had like comprehension, full comprehension, then you could say the union of two sets is a set? Because that's like a property. I guess it's like to me. That's what I think's happening. Like if you had full comprehension, you could get like, I thought maybe said somewhere else, like, I don't know. It's, I don't know. I guess I'm a little confused by that, what he's saying. These axioms are not sufficient to prove that the union of two sets is it. Okay, so I've been thinking about that a little bit, but okay, I hope I didn't. Well, obviously, I've sometimes like, oh, maybe there's things yeah, I just was confusing to me, honestly. Okay, but so I think, yeah, I think it's gonna be really fun. I have like, you know, a few days off, so I'm gonna, yeah, if anyone knows what I'm asking, please let me know. What is, like, I guess I'm thinking, like, does that mean that if we had, like, I'm sorry if it, but like, does that mean if we have, like, full comprehension, then, like, we don't even need all these other axioms. All you need is comprehension. That's what it kind of sounds like to me. It's like, if you have comprehension, you could have anything you wanted. You don't even need those other, you wouldn't even need to have other axioms. That's what I guess that's what I'm kind of, I don't know. Okay. So, yeah, that's all. That's all I wanted to do. And then this has been really helpful too. I did, in the other video, I read I finally found the logical axioms. I didn't realize it was in here. I just saw it somewhere, and I thought, like, my task of the day was find the logical axioms in there. And so I made a video doing it, but then I ended up just, like, couldn't find it. But yeah, so the logical axioms, this is from all well-formed formulas having a form of a propositional tautology, equality axiom, quantifier axioms, and they're all written down and stuff like that. Inference modus ponens. I was gonna try and make a visual of modus ponens, but I'm not sure yet. So I think I have some idea what to do. But okay, thanks for listening. And I just want, oh yeah, I told you about Problemista. Yeah, I just wanted to talk about Kunen and Jech and how fun it is to, like, read the intros now and, like, have an understanding. It's like, there's so much information in there that it's, like, such a great perspective of what's going on. So that's really fun. Okay, I'll see you around the town.